Today we are learning about acids and bases. How do you know if you have an acid or a base? Well, acids produce hydrogen ions when they are dissolved in water. That's because most acids have hydrogen at the beginning of the formula. Look down here. Citric acid has 3 hydrogens out front. These hydrogens that came later don't mean you have an acid. Only the ones out front count to tell you that you have an acid. HC2H3O2 is acetic acid or vinegar. There's a hydrogen out front. Hydrochloric acid has a hydrogen out front. That's stomach acid. Nitric acid, another hydrogen out front. Sulfuric acid, H2SO4, 2 hydrogens out front. So if you have a hydrogen out front, you probably have an acid. Now, water is an exception, H2O. Yes, there's hydrogen out front, but you know water's not an acid. Technically, water can actually act like an acid or a base, but for right now, water is not an acid. Acids taste sour. For example, lemonade has that sour taste caused by the citric acid in the lemons. Citrus fruits like lemons, oranges, grapefruit, those have citric acid, which is the sour taste that you have. Acids will change the color of an acid-base indicator. Litmus paper has the indicator litmus put into the paper, and litmus paper will turn red in an acid. See how red and acid both end with a D, and that will help you remember. Phenolphthalein is clear in an acid, so that is a different indicator that will turn a different color in acid. So litmus paper will turn red in acid, phenolphthalein will be clear, and there's another indicator in hydrangeas, which are a type of flower, and it turns kind of bluish purple in acidic soil. So each indicator turns a different color in an acid. Acids will react with most metals to produce hydrogen gas. That's why acid rain can eat away at a metal statue or a metal bridge, because it will dissolve the metal and produce the hydrogen gas. Then acids will also react with carbonates, like baking soda, to form carbon dioxide. So when you put vinegar, which is an acid, into baking soda, you get these bubbles, and that's the carbon dioxide that's forming. When acid rain falls on a statue made of marble, marble is actually calcium carbonate. And so the acid rain dissolves the statue and eats it away and produces bubbles of carbon dioxide as it eats away the statue. Now, acids have hydrogens, bases have hydroxides. Bases produce OH when they're dissolved in water. Now, the hydrogen for an acid is at the beginning of the formula. The hydroxide for a base is at the end of the formula. Sodium hydroxide has OH at the end, so sodium hydroxide is a base. It is actually lye. If you've heard of lye soap, which is a harsh soap made by your grandparents, well, probably your great-great-grandparents, but that is lye. Sodium hydroxide is the main ingredient in Drano. Potassium hydroxide, calcium hydroxide, magnesium hydroxide, barium hydroxide, ammonium hydroxide, they all have hydroxides at the end, and they are all bases. And finally, sodium hydrogen carbonate, or sodium bicarbonate, is also a base that does not have hydroxide at the end. What happens is that base, when it's placed in water, it rips the water apart and uses the water to make hydroxides. So you just need to know that sodium bicarbonate, baking soda, is a base, even though it doesn't have the hydroxide. Bases taste bitter. Now, we like the taste of sour. We like sour candies, sour lemonade, sour oranges. That's a good taste to us. But most people do not like bitter tastes. Have you ever had unsweetened baking cocoa with no sugar in it? Oh my goodness, it's disgusting. It's really bitter. Have you ever eaten a pecan and gotten that little piece of wood in between the two halves of the pecans? Oh, that is bitter. And have you ever had an unripe persimmon? Oh my goodness, it makes you want to stick out your tongue and wipe it off. It's disgusting. That's bitter. That's how bases taste. Also, bases will change the color of an acid-base indicator. Litmus paper turns red in an acid, it will turn blue in a base. Phenolphthalein is clear in an acid, it will be hot pink in a base. And hydrangeas, if they're planted in acidic soil, will turn blue-purple, and if they're planted in basic soil, will turn pink. So you see, you can't just memorize pink is base, because, well, this one, even though it's red, it's a pale red, so it looks kind of pink. So here, litmus paper is pink or red in an acid. So you can't just memorize that. You have to know different indicators turn different colors. Bases will react with fats and oils to produce soap. So, for example, bleach is a base. So when you wash dishes in bleach, if you've ever done that without gloves, you may notice that your hands start to feel slippery. What happens is the bleach reacts with the oils in your hands, in your skin, and it produces soap. It turns you into soap. Isn't that crazy? So the bleach reacts with you, turns you into soap, and that's why you feel slippery when you're touching the bleach water. Now, sometimes people say, okay, so, ooh, is this a new fat loss program? No, do not do it. You know how dry your skin feels and how cracked and painful it feels after getting your hands in the bleach? That is not a good idea. It does not get the fat inside, it gets the oils on the outside of your skin. So it actually just dries out your skin horribly and is not good. Next, what happens if you have an acid and a base reacting together? That is called a neutralization reaction. The acid and the base kind of cancel each other out. And when an acid and a base react together, they will always produce a salt, which is another name for an ionic compound, and they will produce water. See, the hydrogen from the acid and the hydroxide from the base make HOH. And if you rearrange the formula HOH, there's two hydrogens, so H2, and one oxygen, O. Oh my goodness, H2O. And so that's why when an acid and base react together, the hydrogen from the acid and the hydroxide from the base make water. Then the other ions from the acid and base, you have a positive ion from the base and a negative ion from the acid, that makes an ionic compound, and another name for an ionic compound is a salt. So when you say pass the salt, you mean pass me the sodium chloride salt. But when a chemist says pass the salt, you ask which one? Because many different ionic compounds are considered salts. So for example, baking soda is considered a salt because it has a metal sodium ion and non-metals hydrogen carbonate ions. And so baking soda is a salt. For example, mercuric chloride would be a salt. Even though that is highly toxic, not edible, that's still considered a salt because it has a metal and a non-metal. So that's the difference. When you say salt, you mean sodium chloride. When you say sodium, you really mean sodium chloride. You don't mean sodium metal, which is pure sodium, which blows up when it touches water. So that's kind of crazy. Now I'd like to show you how to tell what the acid, the base, the salt, and the water are in a neutralization reaction. First of all, the acid and base will always be the reactants, and the salt and water will always be the products after the arrow. The acid will have a hydrogen out front, so HCl is our acid in this formula. The base will have a hydroxide out back, so that is our base. On the products, always look for water. H2O is water. The other compound that's left has to be your salt. So, you try this next one. Pause the video and look for which one has the hydrogen, which has the hydroxide, which one's water, and which one's the salt. So, this one has a hydroxide out back, so this is a base. This one has the hydrogen out front, so this is an acid. The acid and the base are both before the arrow. The salt and water are always after the arrow. You will easily be able to identify water, H2O, so the leftover compound is going to be your salt. This is still considered a salt, even though there are no metals in there, because NH4, ammonium, is a positive ion, and NO3 minus, nitrate, is a negative ion. And so that's still a salt. It's still an ionic compound because you have a positive ion and a negative ion, even though this is the one positive ion that doesn't have metals in it. You try the next two, and I think you'll be able to get it. Now, when you want to describe something as an acid, a base, or neutral, then you need to use the pH scale. The pH scale measures how acidic or basic something is. The pH scale goes from 0 to 14. 7 is right in the middle. 7 is neutral. That's easy to remember. But trying to remember, is 0 to 7 acidic or is 7 to 14 acidic? I always used to get those mixed up. So the way to remember that is to alphabetize the words acid and base. A for acid comes before B for base. And when you're counting, 0 comes before 14. Aha! So now, 0 to 7 is acidic, exactly 7 is neutral, and 7 to 14 is basic. The closer you get to 0, the more acidic that substance is. So a pH of 0 is more acidic than a pH of 1. A pH of 1 is more acidic than a pH of 2. By the time you get to a pH of 6, it's just barely acidic. And 6.9 is even less acidic. It's almost neutral. 7.0 is exactly neutral. If you have a pH of 7.1, it's just barely basic. 8 would be a little, just slightly basic, a little more basic, but not much at all. By the time you get to a pH of 13, it's very, very, very basic, and by the time you get to a pH of 14, it's extremely basic. So that's what the pH scale is talking about. This is the same pH scale that you use when you're testing your swimming pool to see if it's safe to swim. If it's too acidic or too basic, it will burn you. Speaking of burning, when an acid burns you, it's because the acid is corrosive. Acids corrode and eat away at things, and that is corrosive. A base is caustic. A caustic base will also kind of corrode away something, but kind of in a different way. It's kind of like getting burned by heat and getting burned by cold. Burning by heat hurts. It burns you, it's definitely a burn. That is, like acid is corrosive. It definitely burns you and it hurts. Not with heat, but with the chemicals. Then cold will also kind of burn you, okay, give you frostbite. It hurts. Now, you're not getting truly burned. It's not the heat, and yet it hurts just as badly as if you had been burned. That's why you can say, oh yeah, I got burned by ice. Okay, it's not really burned, but it hurts just as much. In the same way, you can say that you got burned by a base. A base is caustic. It reacts with your skin. It hurts just as badly as an acid burning, but it's a little bit different in the way it goes about it, and so it's actually caustic. A burn from an acid and a burn from a base both hurt equally, but a base can actually be more dangerous than an acid. See, here's why. When an acid burns you, it hurts immediately. You feel it, you go do something about it. When I dripped a little bit of concentrated acid on the back of my hand, on the skin between my fingers, I felt it. It felt like a bee sting, and I ran to the sink and threw my hand under the water and got the acid off of my hand. So it did not burn me very deeply. But when you get burned by a base, such as bleach, at first it doesn't hurt. It just feels slippery. You don't feel pain. It actually deadens the nerve endings. And so a base When it gets on you, you're like, oh, that doesn't hurt, that just feels slippery. You don't do anything about it, you don't stop it, and so therefore it can burn much more deeply than an acid just because you don't take care of it. You don't say, ow, and go running to the sink. You're like, ah, no big deal. You let it sit there, and then later on it begins to hurt. And then, by then, you've already let it react very deeply into your tissues, into your skin, and that's why bases can actually be more dangerous than an acid. Also, your body is set up to neutralize acids fairly well because a lot of foods are acidic. We like lemon juice, orange juice, sour candies. Those are all acidic. And your body is set up to neutralize the acids. So if you splash a diluted acid in your eyes, you have about 30 seconds to get that acid washed out of your eyes before permanent damage sets in. But if you get a dilute base splashed in your eye, you have about 10 seconds before permanent damage sets in, just because your body isn't set up to handle the bases quite as well as it handles the acids. Either way, don't hesitate, go running for that eye wash fountain and get it washed out immediately. Now, we've talked about the pH scale. Strong acids have a pH near 0. Weak acids have a pH just below 7, but getting close to 7. Weak bases have a pH just above 7, and strong bases have a pH close to 14. So what is a strong acid and base, and what is a weak acid and a weak base? A strong acid or base dissociates completely when it dissolves in water. Remember how we talked about how a salt dissolves in water and that salt dissociates or breaks up into ions? Here, sodium chloride has broken up into sodium ions and chloride ions. It has dissociated into ions. Well, acids and bases also dissociate in water, just like the sodium chloride did. And when they dissociate completely, when every single acid particle dissociates and there really aren't hardly any acids left stuck together, they're all dissociated, then we say it has dissociated completely. And that's what makes a strong acid. A strong acid or base will dissociate completely, conduct electricity very well, and it is a strong electrolyte. Strong electrolytes dissociate completely and conduct electricity. So a strong acid is a strong electrolyte. Sodium chloride is not an acid or a base, it's neutral, so it's just considered a strong electrolyte. Then you have weak acids and bases. Weak acids and bases dissociate partially. They are weak electrolytes. For example, vinegar is a weak acid. Some of the vinegar molecules are stuck together in acetic acid, vinegar particles. Others have broken up or dissociated into hydrogen and acetate ions. And so since some of the vinegar is dissociated and some is not, that's what we mean by a dissociating partially. And that's how you have a weak electrolyte. Gatorade is an example of a weak electrolyte. Some of the particles in the Gatorade dissociate and some do not. And so actually, eating salt tablets is more effective if you want to increase your electrolytes than it is to drink Gatorade. Of course, then again, pure salt water really doesn't taste very good versus Gatorade tastes very good. And so that's why people drink Gatorade rather than just chewing on a salt tablet and drinking some water. If you're in the Army, sometimes they will give Army members salt tablets when they're going on a really long march in the heat. Because when you sweat, you deplete your electrolytes. You know, sweat's kind of salty, and so you're getting rid of some of those electrolytes, and that's why you need to replace not only the water, but also the electrolytes that you've lost. Now, strong and weak is not the same as concentrated and dilute. It sounds the same, but it's not. Strong and weak only refers to whether it dissociates, breaks up into ions, or not. Concentrated and dilute actually means, concentrated means you have a lot dissolved, and dilute means it's watered down. You only have a little bit dissolved. So you can have a strong concentrated acid or a strong diluted acid. And you can have a weak concentrated acid and a weak diluted acid. So just so you know that those are two very different terms and they don't mean the same thing. So let's look at a few examples of this. Hydrofluoric acid is a weak acid. Only some of the hydrofluoric acid dissociates in water. Yet, hydrofluoric acid is poisonous. It will actually attack your bones and cause problems. And hydrofluoric acid, even though it's a weak acid, if it's concentrated and there's lots of it, it will etch glass. Yes, it will actually eat into glass. Isn't that crazy? So you actually have to store hydrofluoric acid in a plastic container because it doesn't eat into plastic, it only eats into glass. Isn't that crazy? So it is a weak acid and yet it is dangerous. Vinegar is another weak acid. When you buy vinegar at the store, you are buying a very dilute solution of vinegar. It's either 4 or 5% vinegar. So it's very, very watered down. But if I go back in the chemical stock room here at the school, I have 99% vinegar. It's called glacial acetic acid. And that stuff is so strong, oh my goodness, it will burn the snot out of you. And if you take the lid off, it will burn your nose just from the fumes of it. You will just be getting away from it as fast as you can. Now you may say, oh yeah, that vinegar burns my nose a little bit, but that's 5%. When you get 99% vinegar, it will burn the hairs out of your nose. It is bad. So if you spill concentrated vinegar on yourself, you will be burned very badly. Versus vinegar that you buy at the grocery store that's very dilute is watered down, and that, shoot, you can drink it. So it's not very dangerous at all. Yet, the concentrated vinegar and the diluted vinegar that you can buy are both weak acids because the vinegar only partially dissociates, partially breaks up into ions. Some of the vinegar breaks up into ions, most of it stays together. Now, hydrochloric acid is a strong acid. It doesn't matter if you've got a lot of hydrochloric acid and it's very concentrated, or if it's been watered down and it's dilute. It's still a strong acid. It will still dissociate into ions and conduct electricity. So, hydrochloric acid is stomach acid. It's a strong acid and yet it's in your stomach because it's not strong or weak that makes it dangerous. Concentrated and dilute is what makes it dangerous. Concentrated acids are always dangerous. Dilute acids may or may not be dangerous depending on what compound you have. Dilute hydrochloric acid, that's like stomach acid. Sure, it's not great, not to be gross, but if you throw up, you feel the burning of the acid as it comes up, and the horrible taste, the sour taste, that's an acid. It burns you, and it's sour. So if you ever wanted to know what hydrochloric acid tastes like, just think about throw up. Sorry. So even though hydrochloric acid is a strong acid, if it's watered down enough, it's not going to hurt you. The hydrochloric acid in your stomach is kind of halfway in between. It's not really concentrated, but it's not exactly dilute either. And that's why your stomach has a special lining inside. The lining of your stomach prevents that stomach acid from eating into your stomach and starting to dissolve and digest your insides. If you get a hole in the lining of your stomach, that's referred to as an ulcer. And ulcers are very painful because the acid can now attack your stomach because it got through the lining of your stomach and it's actually eating into your stomach, which is kind of crazy. So now you know more about acids and bases than you probably wanted to know.